Rena is going to read this to me. Rena, go for it.
An open box with a square base is required to have a volume of 10 cubic
And I'll stop right there. That tells me, tell me an open box.
Open box with a square base is required to have a volume of 10 cubic feet.
Okay, she says, Professor, draw a box for me. And she says she wants this box, I think, to have a square base. So guys, we'll do the best we can here in terms of a sketch. And this might be the one that's on the exam Friday. Try to make some sense of this. Let's say this is roughly, I would like something like this. Step back, not too bad. Now, she wanted that base to be a square, I think, right?
Yeah.
And the volume is supposed to be how much now?
10
10 cubic feet. Right. So the volume is this. 10 cubic feet. Just visualize me pouring that much water into that box. It will hold that much. Woo! She said, make sure, Professor, that base is a square. Did they give me any numbers for the length, width of this thing? Did they say the length was 3 feet or width was 2 feet? I don't think they did they? All I know is it's supposed to be a square, so we'll call this X and X down here. Base, length and width. Is the top open or closed? Open, so I need not worry about the top. It's open. Up here. Okay, the base down here, guys, we're gonna place another X here. Go for it. Another X here, just to show it it's supposed to be a square down there. Did they tell me what the height of the box is? Did they say the height? Should I use an X again? Why am I not going to? That's the mistake I would have made as a student. Why would I not put another X? I've got length, width, and place another X here maybe. Why might I say, oh, Ramsey, close? I don't think so. Why? What would that force that box to be if it were X, X, and X? Length, I heard it. Someone said, what was it?
Cube.
A cube. They didn't say this was a cube. So they did not specify what the height was. So the height, I'm just call it H. Now, as a student just told me, if they had said cube, I would use an X on this. Now, is that true, guys? Now, tell me with the way it's marked right now, what would be the best way to express the volume of this box? And I think we discussed how to find the volume of a box to begin with yesterday. How do you find the volume of a box? Not a cone, a box.
That's where H.
Okay, length times width times height. And we'll apply all those dimensions together. Well, in my case, at this point, I have volume is equal to length is X, width is X, and of course height. Or at this point, I have X squared H. Is that true, guys? Okay. Rena, read a little bit more to me.
Express the amount of material used to make such a box as a function of the length x as a side of the square base.
Hang on. And you told me the volume was 10 cubic feet. So I could at this point say, wait now, if you have the volume expressed as length times width times height, Professor, you have it. Also, she gave me that this was given to me. This is 10. Before I leave it. Maybe they gave that to me. Now, what they want though, all of a sudden they could take a turn here. They're saying, now how much material does it take to build that box? What do you think they're asking me to find? We're discussing volume, they're discussing volume. Read that last part to me one more time.
Express the amount of material used to make such a box as a function of the volume.
They want to know when you go out to buy the material to form this thing, how much material are you going to buy? If you want to build a box like this. So can anyone tell me what are they asking me to find about this box? Not the volume. They're asking me how much material must you buy to build a box? What is that?
Surface area?
Thank you, I heard it, surface area. I have to express the surface area of this open box. So guys, I'm looking for this. Surface area. I'm just call it area, guys, of this box. Now watch what's going to happen. The box is open at the top. You don't worry about the top. It's open. I need to go through and express the area. Thank goodness they're all rectangles. The sides are all rectangles. In fact, the bottom is a square, which is a rectangle. I just need to go through and express the area of each one. Can anyone tell me from way back in elementary school, length times width for this down here would be x times x? Is that true, guys? So we'll start out with an x squared. Now, if the box was closed, that means up here, this is closed, you would get another x squared. Does that make sense? But this one's open, so you need not worry about the top. What else do I have here? The one on the side, let me mark it. This is a rectangle, side of that box. What's its area? Length times width. X times h. Add to that. And it makes sense to jump directly across and consider this side, and of course that's the height again over here, is that's going to give me another xh. Okay, what am I leaving out? I'm leaving out right now the front of the box. Guys, visualize the front of the box, which is going to be another rectangle. What would that front look like in terms of an area? Is that still going to be x times h for the front of the box? Yes or no? And I can't leave it out. Now the back here. Length times width for that rectangle back there, is that another x times h? Looks like at this point I have x squared plus, let me collect like terms. I have 4 of these. Is that true? Now, Marina, tell me, read that last sentence if you don't mind to me one more time.
Express the amount of material used to make such a box as a function of the length x or the side of the square
Oh, so
base.
they don't want you to stop. You get lots of partial credit here at this point. But they don't want you to stop as you have all this area written in terms of x. They want to be a of x, f of x, g of x, all my functions. So they're saying, don't stop here. Make sure your final answer is only in terms of x. Well, the issue is, I have an h. That's got to go. They want all this in terms of x. Now, does anyone have an idea how to get the h to go?
We can find this from volume.
Try again.
We can find this from volume.
Okay, let's go back to the volume. Good, good, good. Look at this. If I need a replacement for h, as you just told me, could I divide through by x squared at this point on that volume? Nice. These cancel. Now, do I have a replacement for h? Now I can take this over and say, wait, Professor, you're going to take this over and put it right here? I am. And now write this as, here it goes, guys, x squared plus 4x, and here goes that replacement for h that was given to me. Let me get some space here. That was, where was it? 10 over x squared. Now, at this point, would I ever be happy? Is this in terms of only x? And that's what they want, a of x. No, a of h, a of x. Now, if I clean this up somewhat, guys, put it out here, the final answer, looking good now, would be x squared plus, Now this last term, don't mess up on this. Let's just clean this up, simplify. I see one of these x's will cancel. Just simplify this, get an x. 4 times 10, that's 40. Over x. If you get down to that point, I'm happy. I know what some of my students will do, and there's no problem with it, but if you get down to that point, I'm happy. By the way, is this only in terms of x now? I don't see anything else. I don't see the h there. Is it in terms of x? Now, sure, I see some students, I know my students by now. Some students say, Professor, can I write like this? Put everything over a common denominator of x. In essence, is that the same answer? And some students would do that, which is fine. Irina, did they ask me to do anything else with this? That was it. Taken directly from your textbook. Even the author of the textbook says, my goodness, that's enough. So I don't ask you to do anything else with it. Okay, they didn't ask you to pour water into it? Oh. That'd be interesting to. Wouldn't that be interesting on the exam? Go ahead and do that, and maybe for extra credit, I'll ask you to pour some water into it and start filling it up with water. Maybe. Right now, I'm happy. Okay. Now, I know there's another problem here, guys, to look at for an application. And I know some of my students may have already looked at these 4 altogether. That last one I have not done, have I? Okay. Irina, do you mind, since you're close by, would you read that to me?
A wire of length x is bent into the shape of a circle. Express the circumference.
Okay, hang on. So we got a wire, and it has a length of, I think you said x.
X.
Okay, hang on. We got x here. Now, from what I heard, she says, take that wire and bend it, shape it into a what?
Into
A circle.
shape of a circle.
Right? So shape this into a circle. Now, what do they ask me about that circle?
Express the circumference of the circle as a function of x.
Express the circumference of that circle in terms of what?
As a function of x.
Oh, as a function of x, c of x. I'm using c for circumference. Now, does anyone recall what that term meant back wherever, circumference? Again. Absolutely, like perimeter. Okay, so that wire has been bent into the shape of this circle. They're asking for the perimeter, the outside there. That's called the circumference. They're saying, can you express the circumference in terms of x here? That I will tell you, as you think about it, the first part of this question is very easy. What do you think the answer is? It is x. It's the length of the original wire. You took the entire wire, shaped it into that circle, so it took that length, there's the circumference. The entire length of the wire was bent into the shape of a circle. The next one, though, to finish this up, they're asking me now to do what?
Express the area of the circle as a function of x.
Find the area. Now, this might require a little bit of work to close this down. In terms of x. A of x. Can anyone remind me from way back? We may have to make a trip one day across the street. I know some of those teachers who are teaching at that middle school across the street. We may have to make a trip over there and just see what they're doing with it one day. Make a little field trip. Yeah, wouldn't it be nice? Go and see what they're doing over there. I'll tell you a little short story about one of my students that came from that school. I'll tell you a short story about that student today. Maybe today if I get a chance. Does anyone recall what the area of a circle is? Formula?
PR squared.
Pi r squared. Pi times radius squared. So they want that, and she's telling me, Professor, they want it only in terms of x. They don't want the r there. They want it in terms of x. I realize that's a standard formula. They want only x in your answer. Guys, radius, I know what the radius is. You know what a radius is of a circle. like that. Anyone give me a start on how would you express the, not circumference, the area? Now, if anyone can lead me to where I want to go, I'm going to feel good. Because this, find the area is not that easy. Anyone see something we maybe try there? Just give me some input. Yes, sir.
We could use the formula 2 pi r for the perimeter of the circle.
Wait, okay, hang on. So you're saying, going back to that circumference, Professor, we know the answer was X there. That means it's common sense. But he said, wait, now don't forget there was a formula also in middle school to find the circumference of a circle. Does anyone recall what that was?
2 pi r.
What's the circumference formula? Oh, we need to make a trip.
2 pi r.
2 pi r. So I could say, wait now. Back up there, we have the answer for the circumference is X. But if I wish, from middle school, I know 2 pi r is the formula for a circumference, right? And now, she's telling me, Professor, that they don't want the r in the answer down here. They want only an X. Can anyone make a connection for me? And hopefully get this in terms of only X and get rid of the r. Anything at all? Look at this. Look at this. And look what you want. You want this in terms of only X. Who has an idea? Yeah, hang one up. Yes?
You could set the 2 pi r equal to the pi r squared.
Oh, no, you're getting close. I thought you were going to say it. No, not that. Easier than that. Take a close look at it. Much easier. I think you guys may be thinking a little bit too much on it. Yes?
Just solve for r.
Look at this. Wait, Professor, go back and solve for r. Divide both sides by 2 pi. These cancel. So now you have r to be that. And what do I need? That's what I need. I need a replacement for r. So let's take this down, something like I did the first one. This is going to be taken down and substituted for r. So we're going to write this now in terms of x. A of x is equal to pi, and then my replacement coming in is x over 2 pi. And of course that's being squared, I think. Yes or no? Is that true? And if I clean that up, by the way, guys, everything's in terms of x now. There's no r. If I clean this up, this is pi times, if I square this, it's x squared over 4 pi squared. Just trying to clean it up now. And it looks like one of these pi's may cancel. Watch my math here. And please tell me at this point, do we have x squared over 4 pi? Yes or no? I'm on top of the board there. Is that true? Is that true? There's no mistake, is there? There's no mistake, is there? Is that it? And by the way, is this answer right here only in terms of for a variable x? That's what they want. So that is the area, A of x. Now see, I realize it's a Wednesday. I see some looks like, whoa, the course is changing already. Professor, could we go back to solving a nice linear equation? It won't be long until you're hoping we go back and complete the square. What should we move maybe into next week? You'll be sitting there wishing, oh, I did not like completion of the square. I missed it on the quiz. But now I wish we were back doing it again. When you see what's coming up. Guys, any concerns here though? Now, I think that page is completely done, is it? Everything can work. Now, if you don't mind, if, and there will be a word problem on the test, Friday. It's going to be one of these. I'm going to just choose one of these. I'm not going to create my own like I usually do. I'm going to just create one of these. Not create. Copy one of these. Now, I know my favorite. I'm not gonna tell you which one. I know my favorite one. Okay, but it's gonna be one of these, so you have to know all four. And how to set them up. Okay, I don't know whether you want to memorize. I don't like that word in math, memorize, but it's gonna be one of these. Okay. Now, with all that said, that takes care of all that. Guys, I was thinking, here we go, part two, part three. Yes. I'll try to keep this organized. I was thinking about something, right here it is. Yes. If we do transformations and talk about transformations, I think one of my students read for us, a horizontal shift to the left, a horizontal shift to the right, vertical shift up and down, all that business. Did we? Okay, let's put it like this. Use transformations. And so we don't have to write so much. Use transformations to sketch this. Here we go. This is going to be a function. And I have mine written like, if I can find it here, beautiful. Looks like that. And you and I are going to do it. Because around here, I'm going to also put transformations in on this. Oh, did I mention transformations on the review that I gave you for the exam? Was transformations mentioned or not? Was that mentioned on the review? It was? You guys agree? On the review for the exam, was there any mention of transformations that you're responsible for? Okay, closer.
I don't see it.
I don't think it's there. I don't think it's there, not transformations. But I'm holding off on that, I'm gonna hold off on that for your next quiz for transformations, but you're not responsible for this. Okay, guys, let's do this. Now, with your help, I need to identify each transformation, I'll write them out, and then I need a parent graph. We looked at a list of parent graphs one day, and I need to apply those transformations on that parent graph. Now, to start out, let's see if I have enough colors here to work this. I hope so. Can anyone tell me, based on, I know you saw this yesterday with me, can anyone tell me what the negative sign stuck out front might do in terms of a transformation? And we talked about this yesterday. It's going to be reflect. Now, are you going to reflect across the x-axis or across the y-axis? It depends. What do you think? X-axis. So this negative sign stuck out front is a reflection through, like that, the x-axis. Now, you've got a square root. Now, place that parent graph for a square root here short down the grid. But I'm concerned now about this. We know what the negative sign up front tells me. And I'll do that shortly here in red. Does anyone recall or maybe see something about the part underneath the square root based on the discussion we had yesterday? Go for it.
It's a negative x, so it would reflect to the y-axis.
Oh, you're getting close, getting close. Are you telling me I should turn these around?
Yeah.
Hang on. So that X should come first. Now tell me one more little item, because you are correct in what you said.
It reflects to the
Now, before I do that though, something else with that green. What would be wise to do before we do his reflection? Yeah, factor out the negative. See it clearly out front, which is going to make a little change. It makes that x minus 4 now. Got to remember to do that. Now, tell us about that negative sign. You said it correctly. Now, this negative sign inside in green, when I get to it, tells me to do what?
Reflected on the y-axis.
Thank you. Reflect through, this one's the y-axis. I'll do that part in green when I get to it. Oh, what a beautiful transformation it's going to be. Now, the x subtract 4, if I'm using different colors here, this part, I gotta show, I'll do it in blue. What do you think the x subtract 4 tells me to do after that? Yeah, to the right, how many units? 4. So a horizontal shift to the right, like that. 4 units. We know it's 4, but it's a horizontal shift to the right. So far, so good? And then I have one more transformation. And since I'm using all different colors, guys, oh my goodness. Let me go back to the, we'll go back to the black. This. What's that tell me there? To finally finish the graph up by doing what? Vertical shift up 3. We discussed all these. Up 3 units. Now, I've got to start out with the parent graph and then apply these to that parent graph and see what the final graph looks like. Now to do that, like I said, I do the parent graph first and move around the board here. You guys on the grid, all students should know what a basic square root graph looks like. And that's going to be my parent. Let's say it does this. See if you guys will agree. We'll label as I move along. Is that what my parent graph should sort of look like? Now your partial credit should show me the parent graph. Now I'll start applying the transformations. I go from left to right. Some of my colleagues who are teaching this will say, Ramsey, I sort of show students do this first, and then do that, then come back. Oh, no. Just go from left to right and get them all out of the way. The first one there that I have marked in red says reflect that graph through the x-axis. All I'm looking for is a graph something like this. I will label it. Keep up with it. That represents that. Red's done. The next, I think, was the green. I'm now supposed to reflect that through the y-axis for the green. That means pick up with red, and now reflect it across the y-axis. And guys, see if you agree, well, it now looks something like that. Okay, and we'll label this as y is equal to, at this point, negative square root negative x. Not quite finished yet. We now pick up the blue. It says now horizontally shift to the right 4 units. Let's try this. To the right 4 units. And I'm doing that in blue, so let me use my blue marker. We're going to take that green graph and say, Professor, are you going to make it look something like this? I am. And therefore, I'm going to label this as representing y is equal to negative square root negative x subtract 4. Everyone agree so far? So far, so good? And finally, since I ran out of colors, last says now shift that graph up 3. Now, I know we know what that means to do. Move up to 3. Hang on, guys, hang on. This blue graph is going to be shifted, I'm going to do it in black, up here. So this point right here, common sense tells me it's going to be here now. This point here, shift up 3. And then would the shape do something like this for my final graph? I don't have it drawn yet. Would the final graph look something like this now when I connect? True? Looks like the blue graph, except it's been shifted up 3. what do you think I may ask you before you put the final graph on the grid? What do you think I'll be asking you to specify for me for the final graph? Besides just doing that, which it's going to do, but I need something. Yes?
Starting point.
Yeah, it could be something else though, something else.
Like where it causes at zero.
Getting close.
domain and range.
Oh, I'm getting domain and range after I get the graph done. What do you think a professor would ask? I would ask for students to do besides just do that. Which, this is the shape it's going to take.
Y-intercept.
I want to know, where is it going to cross the y-axis? And is it going to cross the x-axis? So I'm looking for, before you make that last graph, is where are the x and y intercepts? So on the side here, I need to show, I need to find this, if there is one. And I'll leave some room here, I need to find this, if there is one. Guys, a quick way to find x-intercept, you set the y equal to 0. You say, Professor, what y? That. F of x is y, so if you want to see where the x-intercept is algebraically, before I get back to the graph, set the y equal to 0, and you have this. Let me go back to the original black function. Looks like this. You gotta solve for x. You gotta solve that equation for x. And where it is, that's where my graph's gonna cross the x-axis. If it does. It may not be possible. But guys, to solve that equation, I think most students would tell me, Professor, why don't you move that 3 over to the other side? And then I got a negative here and a negative here, so I could multiply both sides by a negative or divide by a negative, make it look better, and turn these into a positive, which would be much better for me. Everyone agree? Just try to solve that equation, it has a radical in it. Then what might you suggest now here at the end to finish up? That we've done in the class here. Square both sides. Then we end up with 9 is equal to, look at this, 4 subtract x. I'm trying to solve for x. If I finish this simple equation up, middle school problem, x is equal to, I think, -5, guys, make sure I'm correct. I'm gonna write this as an ordered pair. This is my x-intercept. So I'll get back to the grid, make sure my graph, my last graph,